Hey guys, it's Miss Wallace, and welcome to our second week of learning new topics and taking notes from a YouTube video. Go grab yourself a sheet of paper if you don't have one, and let's copy these examples down so you can use them to practice and take the quiz this week. So last week we worked with solving quadratic equations. We're still going to be working with that. We're just going to look at a different method today. So we're going to solve quadratic equations using the quadratic formula. Alright, so last week we were solving quadratic equations, and if you remember, a quadratic equation always is in the form, so let's look at that again. What we call a quadratic equation is always going to be in the form ax squared, that means some number times x squared, either plus or minus, that can be a plus or a minus sign, bx, some number times x, plus or minus, a value, a constant value c is equal to 0. We talked last week about why it's important that it's equal to 0, because if you can factor this into two things that are multiplied by each other, two binomials in parentheses, then you can set each of those equal to 0, and that's what you practiced last week. Well, this week we're going to look at what happens if this is not able to be factored. Maybe you thought about that as you were working last week. Last week we only worked with equations that were able to be factored. And so I'm going to show you an example of what it would look like if it's not able to be factored. So let's look at example number 1, and let's look at the equation that looks like this. So let's say we want to solve for x. Remember, we're still trying to figure out what is that missing value of x, and the equation is going to be 4x squared minus 6x plus 1 equals 0. Now, last week, here's what we would have said, and I'm going to get a separate sheet of paper here, and you can write this down if you want to, but I'm going to do it on a separate sheet of paper because this is what's not going to work. Last week, we would have looked at this and said, okay, this equation it needs to be factored. I need to figure out, something times something else and set it equal to 0, and I need to factor this. So I look at this and I say, well, there's a value out here, my a value. That means I'm probably going to have to use the box method, and so I would have taken 4 and multiplied it by 1, and that would have gave me 4, and I would have then said, okay, I need something that will add together to get -6 and multiply together to get 4. That's the sort of the beginning of that box method process, right? If I'm trying to factor this. And so once I take my a value, multiply it by my c value and get 4, I start looking at this and I ask myself, well, maybe start with the multiples of 4. Well, what if it's, 4 and 1? 4 times 1 is 4, but I can't do 4 plus 1 to get -6, and so that doesn't work. Well, what if I make them both negative? 4 times -1, -4 times -1 does give me 4, but if I add those together, that gives me -5, and so that doesn't work. Well, the only other things that will multiply to get +4 is 2 times 2. That doesn't give me -6, or -2 times -2. Well, that also doesn't give me -6. And so I get stuck here. There actually is nothing, maybe a decimal, a very strange decimal that's incredibly hard to find, that adds together to get 4 that would multiply together to get 4 that would also add to get -6. And so now what do? I can't find my factors. I can't go down here and, start my box method because I don't have my factors, and therefore I cannot factor it. And so you get stuck. And so rather than just throw our hands in the air, although maybe some of you would want to do that, there is another method that we can use to solve for x, and it's called the quadratic formula. Now, I would have to look up the history of this, and that would probably be an excellent, research project for us during this quarantine time, is to look up where this quadratic formula came from. But here is what we're calling the quadratic formula. here is what it looks like, and here's what we're going to use to help us solve this. So I'm going to introduce you to the quadratic formula. Now, this is the definition of this quadratic formula, is a formula or a way, a method for solving for x in a quadratic equation. And here's what this quadratic formula looks like. So of course we're finding an x value, so it's x is equal to, and here is the rest of it. It's negative b plus or minus the square root of b squared minus 4ac, all under the square root, all of that divided by 2a. Now, I'll give you a second to write that down. I'll give you a second to moan and groan about how complicated that looks, but it's really not actually that complicated. We're going to see it in action. All right, so remember, the equation that we're trying to solve is up here. We're trying to figure out the x values. What could I plug in for x in both of these situations? And so we're going to find our x value by completing this formula. Now, you see a lot of like alphabet letters here. There's an A, there's a B, there's a C. Remember, those actually just correspond to parts of this quadratic equation. And so what I'm going to do is I'm going to go through and label and maybe even like draw a square around all of these values up here. So remember, if I'm thinking about my general form, then in this particular equation, my A value is going to be 4. My B value is going to be negative 6 because there's a minus in front of that. My C value is going to be 1. That's just the definitions of what A, B, and C are from our general quadratic equation. And so those are the numbers that we're going to plug into our formula here. And so I'm just going to make a very small little list over here that my A value in my problem that I'm trying to solve, the A value is 4. The B value is negative 6. Got to take that negative. Sign in front of the number goes with the number. And my C value is 1. And what I'm going to do is I'm going to plug it into this formula and I'm going to solve. And once I solve this, it's going to tell me what my X value is. Now, remember, in general, last week we found that quadratic equations usually have how many solutions? Normally they have 2. And so this plus or minus here is actually where we're going to get our 2 solutions from. I'm going to show you in a second how we're eventually going to have to write this formula twice, once with a plus and once with a minus. So right now we're just going to plug in our numbers. So it's negative b. Well, look at our b value. So it's going to be negative. Now my b value is a negative, so I'm going to put it in parentheses. So it's going to be a negative 6 plus or minus. That's from this part of the formula. Then I'm going to put my square root symbol, and then I'm going to put my b squared. So b, again, is negative 6. I'm going to square it. Notice b comes, we've got 2 b's here in a row. So we plug in what we see for b, minus 4 times the a value, which is 4, times my c value, which is 1. Now remember, all of that is underneath the square root symbol. So I'm going to extend that out as far as I need to. So I plugged in my a and my c, and that's all over 2 on the bottom, 2 times a. Well, my a value is again 4, and so on the bottom I'm going to do 2 times 4. Now, I'm just going to start simplifying this. If you need to use a calculator, that's fine, but it's going to almost be like an order of operations problem because we've got a lot of operations here. We have to do them in the correct order. First thing I'm going to notice is that a negative makes a positive. So that number on the outside there, that negative b, just becomes positive 6. It's still plus or minus here in the middle. We're going to deal with that plus or minus here in a second. Now I'm going to work out everything that's underneath my square root symbol here. So negative 6 squared, remember, is not a negative in the end. It's going to be a negative 6 times a negative 6 again, which gives me positive. So that is going to be positive 36. That's negative 6 times negative 6. Minus, again, all this is under the square root, 4 times 4 times 1. Well, 4 times 4 is 16. And 16 times 1 is just 16 again. So that's 16. All over, on the bottom, we've got 2 times 4. So on the bottom, it's just going to be 8. I've got one more step to complete, is to completely simplify this underneath here. And so 6 plus or minus the square root of 36 minus 16 is 10. Not 10, y'all. My goodness. That's 20. Type it in your calculator if you're confused, like I am. 36 take away 16 is definitely 20. And then that's still over 8. All right. Now, 20 is not a perfect square. Like if you type in the square root of 20 into a calculator, it's going to give you a decimal. And so my last step here, because that's not a perfect square and I'm going to get a decimal, I kind of want to avoid decimals at all costs. My last step here is going to be to simplify the square root as much as possible. Now, it's been a while since we've done this. We did this on the review a few weeks ago, but we learned this at the very beginning of the year, that if you have a square root and you want to simplify the thing on the inside, you've got to break down that number first, right? So 20 is really 4 times 5, and 4 is 2 times 2, and there are all my primes. And so square root of 20 is really the square root of 2 times 2 times 5, and I can actually take a 2 outside, and so 2 square roots of 5 is what I'm left with. And so I can rewrite this over here as 6 plus or minus 2 square roots of 5. That's just coming from, I'm simplifying the square root of 20 to 2 times the square root of 5 over 8. Now we're almost there, because remember, these types of problems really have two answers. And so one of my answers is actually going to be x is equal to this problem using the plus sign. So 6 plus 2 square roots of 5 over 8. And then my other answer, or it could be x is equal to 6, and I'm going to take the minus sign this time, this way through. So 6 minus 2 square roots of 5 all over 8. Now, that looks pretty messy, but those are actually your final answers. Actually, the only thing that we could still do is simplify these numbers here, because 6 and 8 are both even, 2 is an even number, and so really the only step left is to sort of simplify our answer, and that's just reducing these fractions. So 6/8 actually simplifies, we can simplify that by 2, so that's going to become 3 over 4 plus, well, 2 over 8 simplifies to 1/4, so I could put 1 square root of 5, or I really don't even need that 1 there, so it's just 3 plus the square root of 5. Or I could do the same thing over here. I can simplify my fractions. 6/8 simplifies to 3/4, and 2/8 simplifies to 1/4, so square root of 5. There could really be a 1 there, but not necessarily. So your final answer is x is either equal to 3 plus the square root of 5 over 4, or x is equal to 3 minus the square root of 5 over 4. And that may look a little messy, but those are our final answers. You could type this into Desmos and check yourself, and let me bring up Desmos and we can plug those in just to make ourselves convinced that this is the solution. And so remember, the original problem that we were solving up here is 4x squared minus 6x plus 1 is equal to 0, and I wanted to know what my x value is. And so if I'm going to type this whole thing back into Desmos, I type in 4 times, in parentheses, x squared. Well, I'm saying that my first value of x is this, 3 plus the square root of 5 over 4. And so I would type in 3 plus the square root of 5, and I need all of that over 4. Oh, I'm going to have to put this in 2 sets of parentheses. So let's do another set of parentheses. So 4 times, in parentheses, and then also in parentheses, 3 plus the square root of 5, square root of 5, that whole thing over 4. So see how I get that with that second set of parentheses on the inside? Because then this whole thing, because it's x squared, this whole thing has to be squared 4 times my x value squared plus no, it's not plus. The original problem was minus. Minus 6. And then again in parentheses, my x value, which I'm saying is 3 plus the square root of 5. Again, I'm going to have to put a second set of parentheses here. 3 plus the square root of 5. And then outside, y'all, I just deleted that whole thing. Can I undo? Oh, good. Oh, that's what that undo button is for. That whole thing over 4. And then I'm going to add 1. And guess what? It works. It comes out to be 0. In the interest of time, I'm not going to plug in the other solution down here. But if you did, it would still come out to be 0. And that's just a way to check yourself to make sure that you're right. So you may be thinking, well, that's a really long process. Let's do it all in sort of maybe a quicker way where I'm not explaining every single step, and let's make sure that we know how to use this formula. Remember, this is sort of the key thing that we're dealing with here. All right, so let's look at a second example. So example number 2. And let's look at this example. So 2x squared minus 5 is equal to 3x. All right, now, remember the first thing we need to check for is that it's equal to 0. Right now, this is not equal to 0, so that's the first thing we want to make sure that we fix. You can't use the quadratic formula if it's not equal to 0, so that's still something we want to do. So I'm going to take away 3x from that side. If I do that, that gives me 0, which is a good thing. And I also am going to subtract 3x from this side. Now, this is an x squared, this is a 5, this has an x with it. So none of these are like terms. We can't combine them. So I'm just going to rewrite it in the proper form. So I'm going to put my 2x squared still. I'm going to put my minus 3x in the middle because that's my b value, right? That's the letter that goes with the x, and then it's going to be minus 5. So we want to make sure that those are in the correct order. Remember, in general, it's always ax squared plus bx plus c is equal to 0. And so I want to make sure that my terms are in the correct order. All right, and so once I get it equal to 0, the next thing I'm going to do is identify what is my a, what is my b, and what is my c. And so in this case, my a value is 2, my b value is negative 3, my c value is negative 5, and then I'm going to copy down my quadratic formula. Now, you're going to probably use this so many times that you actually get it memorized. I'm pretty sure there's a song that helps you memorize this. If so, I'll link it in the next video. But I just had to memorize it when I was in school. So it's negative b plus or minus the square root of b squared minus 4ac, all under the square root, all over 2a. And so we're going to plug in our numbers. And so x is equal to my negative b is negative, b value is negative 3. So negative's always on the outside of the b, but then our b value actually is negative as well. So negative 3 plus or minus the square root of b squared, so that's negative 3 squared, minus 4. 4 is just always the number that's in the formula. Notice that 4 does not come from any of my a, b, c values. It's just there. Times my a value is 2, and then my c value is negative 5. So plug those in, all over 2 times my a value in this case is 2. And you look at that and you're like, that's super long. And now what I have to do is start simplifying it. So start with the outside, start again sort of like order of operations. A negative 3, again we're going to have to change to just positive, so that becomes positive 3. It's still plus or minus the square root of, we're going to work these two things out inside here, the things underneath the square root. So negative 3 squared is not negative 9. Negative 3 times negative 3 is positive 9. You could type that in the calculator. Make sure you put your negative in parentheses if you do. Minus 4. Oh wait, let's not do 4. Let's go ahead and multiply those things together. So 4 times 2 times negative 5. Well, it's minus 4 times 2 is 8. 8 times negative 5 is negative 40. But there's already a negative out here, and so if you even wanted to treat that sort of like a negative 4, 4 times 2 times 5 is going to be 40, and it's a negative and a negative, so that's actually going to be plus 40 coming from that end of the equation. And then it's all over 2 times 2, which is 4. And so the last thing we have to do is complete this square root. Well, there's something really nice going to happen here, because what is 9 plus 40? Well, that's 49, and 49 actually is a perfect square. Earlier, remember, we did not come out with a perfect square. We came out with 20 over here, and so 20 had to be simplified because 20 is not a perfect square, and we had to do a lot of extra work over here to the side. It's really nice, and you can jump for joy when this number underneath the square root comes out to be perfect, because we can actually take the square root. It just makes life a little bit easier and a little bit simpler. So x is equal to, it's going to be 3 plus or minus the square root of 49 is 7. And so we just put a number there, we get rid of that square root, and it's all going to be over 4. Now, once you have simplified all of your numbers, so we've worked out everything sort of according to order of operations, the only thing left is to remember there's two cases here. There's the plus and then there's the minus on the top. And so now is the time where we split it up into, okay, my answer is either 3 plus 7 over 4, or my answer is x is equal to 3 minus 7 over 4. And so now I'm going to work out my two cases. And so x is equal to either 3 plus 7 is 10 over 4, or x is equal to, well, 3 minus 7 is negative 4 over 4. And I can take this, I can simplify them one more time. If it's an improper fraction, you don't necessarily have to change it to mixed, but if it can be simplified, we want to simplify it. 10 over 4, both of those will divide by 2, and so we get 5 over 2. So 5 halves is one of my answers, or x is equal to negative 1. And so those, x is either 5 halves or negative 1. And again, you can type that into Desmos and double check yourself and make sure that it works. And so I'm going to type in my original problem. Now I'm going to go back to where I was getting my a, b, and c from. And so I got 2 times my x squared. Well, first I'm saying that x is 5 halves. So 5 divided by 2 squared. My original problem was then minus 3x, so minus 3 times, these are a little easier to type in when you don't have the square root, my x value, which I'm saying is 5 halves, and then the last part of the equation was minus 5, and we want to make sure that that equals 0. And it does, so 5 halves is a true value for our x. And then I also said, well, x could have been negative 1. Negative 1 should also work. And so I'm just going to replace, this is again a little easier to type in, I'm just going to replace the negative 1 or the 5 halves with a negative 1, and that also comes out to be 0. And so again, this is just a way, this formula here, the quadratic formula, is a way of finding your x values when you are not able to factor. Actually, this formula will even work for questions that were factorable. We could have used this last week. It's a little easier since we already knew factoring, but this formula works for everything that is in this form, everything that would be in a quadratic standard form. All right, let's look at another example. This may be our last example that we do on this video. So let's look at our last example. So let's try one that's like this. 2x squared minus 7x minus 13 is equal to negative 10. So again, our first goal is to get it equal to 0. So we want this side to be equal to 0. Well, that's really easy to add 10 to make that 0. Negative 10 plus 10 is 0. If I added 10 to this side, I'm going to add 10 to this side. Now notice on this side, we actually do have some like terms to combine. On the last problem, we had an x squared and a number, but we were trying to combine a x, and so we just had to kind of stick it in the middle. This one actually does have numbers, solid numbers without x's that we can actually combine. And so we're going to do that. So 2x squared minus 7x, and we're going to add negative 13 plus 10. Well, if I do that, that gives me negative 3. And so now my problem is in standard form. Now I pick out my a value, which is 2, my b value, which is negative 7, make sure you take that negative, and my c value, which is negative 3. Remember, the sign goes with the number. So identify your a, b, and your c, write down your formula, plug in the numbers. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, copy it down with the letters first. That way you're not confused about where you're trying to plug in numbers. So yes, you do need to show this step every time when you're copying it down. Just keeps things organized and straight. All right, we're going to plug in -7. Now, this will not always be a negative. I feel like the examples I've done have come out to be negative. But if this were a positive 7, you would just put -7 and you'd be ready to go. We're coming out with negatives here, which is making that positive. All right, so -7 plus or minus the square root of -7 squared minus 4. And then my a value is 2, my c value is -3, all over 2 times 2, which is 2a. Ready to start simplifying my numbers. So x is equal to -7 becomes +7. Remember, if that had been positive, your answer here can be a negative number. We just haven't done an example like that. Plus or minus the square root of, ready to simplify the inside. So I've got -7 squared, that's -7 times -7, which is 49, minus 4 times 2 times -3. Well, 4 times 2 is 8, times 3 would be 24, and it's a negative and a negative, so that actually ends up being plus 24. So again, you can think of this as like a -4, or you could think of this as 4 times 2 times -3, which would be -24, and then it's minus a negative, so it ends up being plus 24. Either way, 2 times 2 is then 4, and we have numbers underneath our radical that we need to add together, and that ends up being 49 plus 24, which ends up being 73. So 7 plus or minus the square root of 73 all over 4. Now 73 is not a perfect square. There's nothing times itself that will give you 73. If you type in the square root of 73 into your calculator into Desmos, you get a long decimal. So it's one that we're going to have to try to simplify. If you take 73 and you try to simplify it, and I mean maybe you even try dividing it by several things, 73 is not even. It will not divide by 2. Let me show you this. It will not divide by 2 evenly. It does not divide by 3 evenly. It does not divide by 4 evenly, or 5, or 6, or 7, or 8, or 9, or 10, or 11, or even 12, or 13, or 14, or 15, or 16, or 17, or 18, or 19. And so you might be thinking to yourself, well, man, does 73 even divide by anything? And here's what I would suggest maybe even doing is to Google, is 73 prime? Is this a prime value? And yes, Google is nice enough to tell us 73 is prime. 73 will not divide by anything. We can't simplify it. So if you can't simplify this, you're done. We just have to write these as two different answers. So either x is 7 plus the square root of 73 over 4, or x is equal to 7 minus the square root of 73 over 4. And that's as far as we can take it. Either the plus answer on top or the minus answer on top. I will leave it to you to type that back into Desmos to double check yourself and make sure that, yes, if I do replace x with this number, it does come out to be 0. But sometimes, a lot of times you're going to end up with answers that look like this. You're going to have a number plus a square root over some number, and that's fine. Sometimes, in very nice cases, it actually will come out to be maybe a whole number or a fraction. Those are nice cases, but a lot of times your answers are going to come out to look like this. And so those are your notes for today. That is solving a quadratic equation using the quadratic formula. This right here you want to either memorize or always have in front of you as you're working these problems. And please feel free to email me or attend our Zoom sessions this week on Monday or Wednesday at 3 o'clock to ask questions or to maybe see some more examples about these. Thank you guys.